Have you ever seen a picture of an offshore oil rig? They're just these incredible, massive engineering marvels. They are basically cities at sea, operating in some of the most hostile environments you can possibly imagine. So it makes you wonder, right? How on earth do these multi-ton giants, getting battered by storms day in and day out, keep everyone and everything safe? Well, it turns out there's a rulebook for that, and we're going to dive right in. So here's the game plan. We're going to break down the International Safety Bible for these rigs, called the MODU Code. First, we'll get into what the code actually is. Then we'll see how it helps a rig literally survive a storm. After that, we'll look at the heart of the machine, its emergency plans, and finally, why the safety checks never, ever stop. Okay, so let's start with the absolute basics. Before we get into all the cool safety systems and emergency procedures, we first have to understand what exactly we're talking about and what the official rulebook is that governs its entire existence. So the official kind of fancy name is a Mobile Offshore Drilling Unit, or MODU for short. Now, the two key words you really want to focus on here are vessel and mobile. See, unlike a platform that's fixed to the seabed, a MODU is designed to move, to operate, and most importantly, to survive out on the open ocean. And that, as you can imagine, brings a whole unique set of challenges. And that is where the MODU Code comes in. It's the global standard for safety, put together by the International Maritime Organization. You should think of it as the master blueprint for building and running one of these things. It dictates everything from the specific type of steel you have to use all the way to where you have to place the lifeboats. And it's all for one reason: to protect the rig, the people on it, and the ocean around it. All right, now let's tackle the most fundamental challenge of all: just staying upright. I mean, how do you keep a massive structure from tipping over in the middle of the ocean? Well, the MODU Code is what gives these giants their sea legs, laying out all the engineering rules to fight back against the incredible forces of the sea. And look, this is not just a theoretical question. The code specifically demands that these units be able to handle truly severe storm conditions. So really, how do you engineer something the size of a skyscraper so that it doesn't just get knocked over when the weather gets nasty? Well, the first thing to know is that not all rigs are the same. A self-elevating unit, which basically stands up on giant legs on the seabed, faces totally different challenges than a column-stabilized unit, which floats on huge underwater pontoons. So naturally, the MODU code has very specific, very different rules for each type, because each one fights against the wind and waves in its own unique way. When you boil all the complex physics down, it's really a constant battle between two opposing forces. On one side, you've got the healing moment. That's a fancy term for the wind and waves trying to tip the rig over. And on the other side, you've got the righting moment. That's the rig's own design and buoyancy trying to push it back upright. The golden rule of the entire code is simple. The righting moment has to win, and not just by a little bit. It has to win by a huge margin of safety. A huge part of that safety margin is built right into the structure. Just like a military ship, the code demands the rig be divided up into a bunch of separate, watertight compartments. The idea is simple, but absolutely critical. If the hull gets punctured, the flood is contained in just one small area. It stops one single point of damage from threatening the entire rig. So, a rig is more than just a stable platform. It's a floating, power-hungry industrial city. So now, let's take a look at what you might call its heart, lungs, and brain. The critical machinery and the electrical systems that keep the whole thing alive and working. When it comes to all the essential systems that keep a rig running, the most important number in the entire MODU code is 2. Now, why 2? It all comes down to one powerful concept: redundancy. The code basically says that for pretty much every system that really matters, you have to have at least 2 of them, and they have to work independently. 2 main generators, 2 fire pumps, 2 bilge pumps, the list goes on and on. And the logic is just crystal clear. If one fails, there's a backup ready to take over immediately. It makes sure that one broken part doesn't cause a total disaster. And get this machinery isn't designed to work on a calm, perfectly level floor. The code demands that all this critical gear has to function perfectly, even when the entire rig is tilted at an angle of up to 15 degrees. It's designed to work while it's being tossed around in heavy seas, which, is exactly when you need it to work the most. So even with the best designs and tons of backup systems, you still have to plan for the absolute worst-case scenario. You just have to. So a huge part of the MODU code is focused on what happens when things go seriously wrong, especially when it comes to fire and having to evacuate.
One of the key strategies is building boxes within boxes. You see here how different areas are separated by these fire-rated walls. That A60 rating, for example, means that the wall is built with steel and insulation that can stop smoke and flames from getting through for at least 60 minutes. It's all about containing a fire in one spot, buying everyone else on board precious, life-saving time.
In a real emergency, chaos is your worst enemy. That's why the code demands clear, well-practiced procedures. The second that general alarm sounds, everybody knows exactly what to do. There's no guesswork. You go to your assigned muster station, you put on your life jacket or immersion suit, and you get ready to board the lifeboats. They drill this constantly, relentlessly, until the whole process becomes second nature. And when it comes to the lifeboats, the code plans for an unbelievable worst-case scenario. It's not enough just to have a lifeboat seat for every person on board. No, the rig must have enough lifeboat capacity to save everybody, even if a fire or some kind of damage makes all the lifeboats on one entire side of the rig completely useless. It is the ultimate fail-safe. You know, a rulebook is pretty useless if it just sits on a shelf collecting dust. So the final piece of this safety puzzle is all about making sure the code is actually being followed, and just as importantly, that it keeps evolving. This isn't a static document. It's a living system of inspection and constant improvement. These rigs are under constant scrutiny their entire lives. Before one can even start working, it goes through a massive top-to-bottom initial survey. Then it gets an annual checkup, a more detailed inspection a couple of years later, and then a full-on deep-dive renewal survey every 5 years. It's a relentless cycle of inspections designed to ensure that rig stays compliant with the code. And this isn't some generic safety pamphlet. Every single MODU is required to have its own unique, detailed operating manual on board at all times. This book contains the precise stability data, the specific emergency plans, everything for that rig. It ensures the crew has the exact playbook they need right at their fingertips. And that brings us to what might be the most important point of all, taken right from the code's own introduction. It says the code should not remain static. It has to be reevaluated and revised based on experience and new technology. And that really is the ultimate lesson here. Safety in the world's harshest places isn't some finish line you cross. It's a constant, never-ending process of learning from the past to prepare for a future that will always, always find new ways to test you.